Hello class, Mr. Mommy here. I hope you're all doing well. Today we are going to have our last lesson in this unit, the exponent unit, and we are going to look at transformations of exponential functions. We are going to start by reviewing the mapping notation, and then we are going to see how we can graph exponential functions that have gone through some transformations. Now, if you remember from our previous unit, in unit 1, if we have a basic function y equals f at x, and it goes through a series of transformations, factor a number being multiplied by the function, then we had the p and k which worked on our x values, and q which was a number being added to this function. The mapping notation said that if you have point x and y on your original function and you have the table of value for your original function, you can find the corresponding points on the transformed function by using the x will be transformed into 1 over kx plus p, and y will be transformed to ay plus q. A, if you remember, was the factor which would do the vertical stretch or compression, and also reflection. Our p-value was the value that, if you remember, we would always look at the opposite of what we would see here. That was the shift or translation left or right, depending on the value of p. Then we have the k value, which was a horizontal stretch or compression. However, it was by the factor 1 over k. And the q value which we had here was actually the value which was shift or translation up or down. Now, it may have been the case that we used C and D in the first unit. Depends, different textbooks or different documents. So I want you to feel comfortable if instead of using P and Q, like C and D, you're comfortable using those two letters. So now let's do some examples here. The first example here, which we are going to do, is f at x equals 3 to the exponent 1/2 in brackets x plus 1 plus 4. So first thing to do, as we did before, was to recognize what's the basic function, and then based on the values of the transformation, we want to try to describe the transformations, and then we will use mapping notation to sketch the graph of the function. And then after we've done that, we are going to state the domain and range of the transformed function. So the basic function here is y equals 3 to the exponent x. And if you look at the values here, a is 1. There is no number which is multiplied by the basic function. Our k is 1/2, which is here. P value comes from here. We said it's always the opposite of this, so -1. And this is our Q value, which is 4. Now, we don't have any vertical stretch or compression because A is 1, but K is 1/2. So we have horizontal stretch by reciprocal of this value. So 1/2 will be by factor 2. Now our P is -1, so that means shift. Negative means left 1 unit, and then shift Q is 4 up 4 units. Now please pay attention to the fact that the horizontal asymptote of the basic function will only be affected by the shift up. So that's the only thing which will affect the location of our horizontal asymptote. So now let's go and do the mapping notation. So now we are going to write the mapping notation and actually graph this function. So to recap, our A value was 1, K was 1/2, P was -1, and Q was 4. So we are going to rotation X and Y. One over K, or the reciprocal of K, is going to be 2x minus 1, and AY 1 times Y, which is Y plus 4. So X and Y, -2, -1, 0, 1, and 2. So if you remember, the basic function here was y equals 3 to the exponent x. 3 to the exponent -2 is 1/9. 3 to the exponent -1 is 1/3. 3 to the exponent 0 is 1. 3 to the exponent 1 is 3. And 3 to the exponent 2 is 9. And now we are going to find the transformed points, 2x minus 1 and y plus 4. So 2 times -2 is -1 is -5. So for those of you who forgot, you get your x and y values from the original points in each point, and you sub it here to find your transform point. 2 times -1 is -2 minus 1 is -3. 2 times 0 minus 1 is -1. 2 times 1 is 2 minus 1 is 1, and 2 times 2 is 4 minus 1 is 3. So these are our x values, and now we do 1/9 plus 4. As I said before, it's easier if you use your fraction calculator. 37/9, which is approximately 4.1. Then 1/3, 1/3 plus 4 is 13/3, which is 4.3 approximately. Then 1 plus 4 is 5, 3 plus 4 is 7, and 9 plus 4 is 13. Now, an important thing to remember is that our horizontal asymptote, which is originally y equals 0, which is the x-axis, is going to be, you can put that also in your transformation. So the horizontal asymptote will be y equals 4. 0 plus 4 is 4. And what I'm going to do is, it's sometimes very helpful if we actually start by drawing the horizontal asymptote as our guideline. So x and y value. 1, 2, 3, 4. Actually, I am going to use a different grid here because I won't be able to fit my scale here. So let me do the graphing here. So y value, x value, so 0, 1, 2, 2, 4, 1, -1, -2, -3, -4, -5, and then here I'm going to go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now, as I said before, I'm going to start by drawing the horizontal asymptote, which is here. Y equals 4, and now I am going to draw my points, -5 and 4.1, -3 and 4.3, -1 and 5, here, and 1 and 7. So this is 4, the 5 is going to be here, sorry. So 4, 6, 7 is going to be here, and then 3 and 13. So 2, 4, 6, 8, 10, 12, 13 is going to be here. F at x equals 3 to the exponent 1/2 x plus 1 plus 4. Sorry, these 2 points. We had -1 and 5, which was here, and we had 1 and 7, which was there. Sorry, I initially put it in the wrong place. Okay, so this is 1 and 7, and then this is maybe I want to put the 3 here too. So 3 and 13. Now let's do one more example here. The last example for today is f at x equals 1/2 to the exponent negative x minus 3 minus 2. Now, the basic function here is y equals 1/2 to the exponent x, meaning that our base is less than 1. Now, our a again is 1. There is no number being multiplied by this. Our k is here, which is actually -1. P is coming from here, opposite of this number, which is +3, and our q is -2. So first of all, we want to describe what kind of transformations are happening. A is 1, so there is no vertical stretch or compression. K is -1, meaning that we have horizontal reflection. Over y-axis. P is +3, so that means shift right 3 units, and Q is -2, which means shift down 2 units. Another reminder that the only thing which will actually have effect on our horizontal asymptote is shift to the down. Now we are going to use the mapping notation to graph this function. Again, I'm going to use a different grid. So okay, so just to recap, our A is 1, K is -1, P is 3, and Q is -2. That means that we're transformation mapping notation. X and Y will be transformed to 1/k is -1, so -x plus P plus 3, and A times Y, 1 times Y plus Q, so Y minus 2. So we make the table of values for our basic function, which is 1/2 to the exponent x, -1, -2, -1, 0, 1, and 2. 1/2 to the exponent -2 is the same as the reciprocal, so 2 squared, which is 4. 1/2 to the exponent -1 is 1/2 reciprocal and then to the exponent 1, so it's 2. 1 to the exponent 0 is 1. 1/2 to the exponent 1 is 1/2, and 1/2 to the exponent 2 is 1/4. And now we are ready to make the table of values for the transform point. So -x plus 3 and y minus 2. So -2 is 2 plus 3 will give us 5. -1 is 1 plus 3 is 4. 0 plus 3 is 3. -1 plus 3 is 2. And -2 plus 3 will be 1. Now y minus 2. 4 minus 2 is 2. Then 2 minus 2 is 0. 1 minus 2 is -1. 1/2 minus 2 is negative 1.5. So it's 0.5 minus 2 is negative 1.5. Then we have 1 over 4 minus 2, which is negative 7 over 4, which is approximately, I'm gonna write it here, negative 1.70, or exactly. Now again, horizontal asymptote, y equals 0. We are going to put this here where the transformation for y is, so our horizontal asymptote will be at y equals negative 2. Now we are ready to do some graphing. Y, and let's move this a little bit. So we have our x value here. So 1, 2, 3, 4, 5, and here 1, 2, 3, 4, negative 1, negative 2. As I said before, the best place to start is always to start by drawing our horizontal asymptote. Y equals negative 2. And now let's put our points in. 5 and 2, 4 and 0, 3 and negative 1, 2 and negative 1.5, and negative 1.75. We know that the function gets closer and closer to the horizontal asymptote. F at x equals 1/2 minus x minus 3 minus 2. Now, some of you may ask yourself, how come if we had a base which is less than 1, we were expecting a decreasing function. So how come this is an increasing function? The key is here in this k value. Because our k value, okay, because our k value is negative 1, we had a reflection in the y-axis, meaning that the original basic function is actually a decreasing function, but because of the reflection in y-axis, it actually changes into an increasing. There are some homework. As I said, most of this is the review for this lesson, is what we've already seen in first unit. However, this time we go into more details about our exponential functions. Stay safe until we have another lesson. Goodbye.